Hello, welcome. Let's try to solve another Leetcode problem 760 for anagram mappings. So for this problem, we are getting to nums array, nums1 and nums2. So for nums1, there's going to be a mapping to nums2, but there are also duplicate numbers. So definitely we're going to have a mapping. So for example, for this 12, this is going to be the first index, and inside the nums2, it's going to be at index 1. So we're going to from index 0, we're going to get an index 1. And similarly for this 28, so from index 1, we're going to get a mapping of index 4. Yeah, so this is the meaning of the problem. And we just need to return such kind of mapping array. So, yeah, the first idea is normally if this is an easy problem, definitely there are going to be many ways to solve it. Because it's not like hard problem. Maybe there are going to be like, one or two ways to solve it. But for easy problem, there are going to be many different ways. So let's just write the first way. So for any number inside the nums1, so we're going to solve it according to the description. Now we're going to find the index. So we're going to use the nums2 and check the index for this number. So after we get this number, we're going to put it inside of the result array. So now we're going to return the result array. So the result array is empty from the beginning. But after that, we should know that if there's a duplicate, what's gonna happen? So for example, this 12, we're gonna find this one. What about there's another 12, but it should be another index? Yeah, because we're gonna have a one-to-one mapping. It's not one-to-many. Yeah. How can we avoid that? We can just set nums2 with the placing index I to any number, maybe infinity, because inside the nums2, there's gonna never be a number which is infinity. If we set it to infinity, it means inside the nums1, there will never be a number which is equal to infinity, because number is from 0 to 10 to the power 5. Yeah. Now let me just run it and submit it to tag. Yeah, as you can see, it works and it's pretty fast. And there are going to be many different ways to solve the problem. So another way is mapping. So because this is a n squared time complexity, but we can still find a method of n log n time. So another one is mapping. So what about we just prepare nums1 with the index? So this is the hash table idea. Yeah, because definitely the index is going to always be unique. Now we're going to put the index inside ni. So for I n in enumerate of nums1. So we're going to put the index inside a tuple. And similarly for nums2. Yeah. So ni for I n in enumerate nums2. So this is going to be the nums2. Now we should know that nums1 and nums2 with index inside tuple. So this means we can sort it. So for nums1, we're gonna sort it. So after sorting, we know that it should be like 12, 28, 32. Yeah, it will be sorted in increasing order. And similarly for nums2. Now we're gonna have the meaning, and we're gonna have the mapping because nums1 is sorted and nums2 is sorted as well. Yeah. Now what are we gonna do? We just needed to take out the index as a tuple. So we're gonna put it as a result. So the index is gonna be something like AB. So for AB in zip, nums1 and nums2. But A is a tuple, B is a tuple as well. So it means we need to take out the index actually. So the index is at position 1, and similarly for B. Now we have the index mapping. Yeah, but we need to sort the result array according to the index for A. Yeah. So after sorting, we can just get the final result. It's going to be the second position. So A1 for A inside the result. Yeah. So this is the idea. Another way to solve the problem. As you can see, it also works. Yeah. Basically, we just need to write this code and copy. Everything is just copy and paste. Everything is about sorting. But now, as you can see, it's really fast because the time complexity becomes n log n. Why? Because for here, this is the O(n) time, right? Here is also O(n) time. So this is n log n time, and if we zip them together, this is also O(n) time. So this is the n log n time. So the final complexity gonna be n log n. So this is another way to solve the problem. Thank you for watching. See you next time.